Today we're going to talk about lesson 4.1 and we're going to start with task 1. So if you want to follow along, you can. Alright, function operations. So investigate combining functions. You have combined algebraic expressions using all of the basic arithmetic operations, addition, subtraction, multiplication, and division. Similarly, you can use these operations to combine the expressions that represent two functions so that you can write a new function. So how can you create new functions by using arithmetic operations to combine two functions? Alright, so let's look at the table, and it says fill in the table. So they give us f of x equals this, and g of x equals this. So it says evaluate for these three values of x. So if we substitute this in for x, that will give us f of negative 1. So first we're going to find f of negative 1 for negative 1. So if we plug negative 1 in for x, negative 1 squared is 1. 1 times 2 is 2. Then we're going to take 2, substitute it into f of x. 2 squared is 4. 4 times 2 is 8. And then 5 squared is 25. 25 times 2 is 50. Alright, now we're going to look at g of x. G of x says take x and add 5. So negative 1 plus 5 is 4. 2 plus 5 is 7. And 5 plus 5 is 10. So all we had to do was plug the values of x in to each function to evaluate the function. Alright, let f of x and g of x equal the same thing. So these are the same functions. Use the values of f of x and g of x to evaluate each expression. So this time we want to do f of x plus g of x. Alright, so if we do f of x plus g of x, f plus g, 2 plus 4 is 6. 8 plus 7 is what, 15. 50 plus 10 is 60. Now the second column says take f of x and subtract g of x. Okay, so f minus g. So 2 minus 4. 2 minus 4 is negative 2. 8 minus 7 is 1. And 50 minus 10 is 40. Then it says we're going to multiply f times g. So 2 times 4 is 8. 8 times 7 is 56. And 50 times 10 is 500. Alright, now we're going to do f of x divided by g of x. Alright, so f divided by g. 2 divided by 4. 2 over 4 reduces to 1/2. 8 divided by 7. That's an improper fraction. We can just leave it as 8 over 7. And 50 divided by 10 reduces to 5. Alright, so you could have plugged them in here again, but since we had already knew what f of x was and g of x, it was easier to use the table above. Alright, now it says now combine the expression in x that defines f of x and g of x by using the 4 arithmetic operations to obtain algebraic expressions for the combined functions below. Simplify the resulting expressions. Alright, so it's saying take the actual functions. So we're going to take 2x squared and add it to x plus 5. So 2x squared plus x plus 5. And then we're going to do 2x squared minus x plus 5. But if you minus that expression, should be negative. And then we're going to multiply it. If you multiply these two, 2x squared times x is 2x cubed. 2x squared times 5 is 10x squared. So that would be this one. And then 2x squared divided by x plus 5 is your answer there. Alright, now it says evaluate each expression for negative 1, 2, and 5 again. Alright, so this is going to be our f of x plus g of x. So it should be exactly the same as up here. So we did f of x plus g of x. We got 6, 15, and 60. So we got 6, 15 and 60. We're plugging the same values in. We're just looking at it in a different way. This time they combine the functions first and then substituting the value. But it's the exact same thing. So we've got subtraction. So we got -2, 1, and 40. -2, 1, and 40. 8, 56, and 500. 8, 56, 500. And then division. All right, division we've got one half. Sorry, I got distracted there. 1/2, 8/7, and 5. Alright, I think there's a typo in the chart here because these should be exactly the same as this up here because this is f divided by g and right here this is f divided by g. So maybe they wanted us to put 2 divided by 4 instead of 1/2, but that's just an equivalent expression. Alright, on the next one it says compare the table from part A with the table you created from part C. What do you observe? The values are the same except for the one that was incorrect. So the values are the same. And what can you conclude from your answer to part D? Performing operations on the function expression and then evaluating the resulting single expression for specific values gives you the same results as evaluating each function for a specific value and then combining. So basically it's saying you can combine the functions first or you can substitute the values into each function first, but when you combine them you're going to get the same result, which we've seen from the two tables. So when combining functions, how does division differ from addition, subtraction, and multiplication? Well, the domain, remember you can't divide by 0. So anytime you're talking about division, you may have a restriction. So the domain of the quotient function may have, let's see what our choices are, restricted values on the domain that the other functions do not. This is because the quotient function will not be defined for any value of x for g of x equals 0. So remember it was f of x divided by g of x. G of x would be the denominator. So your denominator cannot be 0. So that's what that's saying right there. All right, so that's task 1. If you have any questions, let me know. All right, this is 4.1, task 2, if you want to follow along. All right, so operate with functions. In the building understanding, you saw functions combined using arithmetic operations to produce a new function. The table summarizes the 4 basic function operations. All right, so what this is showing you is like they're basically naming what we did a new function. So they're saying h of x is the new function you get when you combine f plus g. And this is just a different way to write it than this. This means the same as this. You can see there's the equal sign there. So you can write f plus g of x, and that equals f of x plus g of x. And same thing with subtraction, multiplication, and division. There's 2 ways to write it. So what they're doing is just saying these are some operations, and they're just naming these h of x once you combine them. All right, and also you can see we talked about division on the last one. When your denominator, when you have a division, your denominator cannot be 0. Okay, that's just a restriction there. All right, so it says let f of x and g of x be these 2 functions. Find f plus g and f minus g. Simplify your results. All right, so f plus g of x, so it takes the 2 functions here, and it's going to combine those. So we're going to combine those. Because we're adding or subtracting, you're not using distributive property, so we're going to use associative property and commutative property. So you can see that associative property means you just kind of rearrange things, and so you can rearrange to put your x squareds together, you can rearrange to put your x's together, and then your numbers. Alright, so you're not going to do subtraction here because we're not using subtraction, we're not doing multiplication, and distributive property we didn't need in this case, so I believe those are the only two properties we need. Alright, B part says how can you justify the result in the third step below from the subtraction expression in the second step. Alright, so f minus g of x, so it's the same two functions from above, so this is f of x and we're going to subtract g of x. Now remember when you're doing subtraction, you are subtracting this whole expression from this whole expression here. So you do have to distribute that negative sign now. So it says, how can you justify the result? How can I justify the third step? Well, negative times x squared is negative x squared. Negative times 7x is negative 7x. And negative times 8 is negative 8. So to justify that you had to use distributive property. All right, that's all for task 2. If you have any questions, let me know.